Welcome to this tutorial on agent-based modeling for psychologists. When I use the term psychologist here, I mean people interested in behavior, cognition, and groups. They're interested in the level of analysis associated with individuals, typically. We're not going to be discussing ecology, economy, epidemiology, disease modeling, environmental modeling. We are interested ultimately in stuff people do. This is an introduction designed for people who might not have any background in coding or programming. I myself didn't before I learned how to write code for agent-based modeling in our program Netlogo. And I've been using this program for more than 10 years at this point. I learned how to use this program in a different way than I'm going to advocate today. And basically, I'm trying to produce the kind of series that would have been useful for me 10 plus years ago. That said, there are a couple of excellent resources today that I highly recommend. The first is this book by Paul Smaldino. It's called Modeling Social Behavior, published by the Santa Fe Institute. It's an excellent textbook. By the time we finish this course, or at least the course that I intend to put up here on YouTube, you'll be about 2/3 of the way through this book, and you'll be able to fully understand pretty much what's been done in any models published. Paul does great peer-reviewed work that's published on using this methodology and in the space of psychology and cultural evolution, so I'd strongly recommend you looking into his work. And the second resource is a book called Agent-Based Modeling for Archaeology, Simulating the Complexity of Society. This book is free, unlike Paul's. If you'll need to purchase that or ask your university library to order some copies in, please do that. This one's free and also published by the Santa Fe Institute. It's one of the most beautiful textbooks I think I've ever had the pleasure to teach with or work from. Depending on what you're interested in, you may or may not find it as useful as Smaldino's book, but there is plenty for people to get out of as well. Now, most of these tutorials begin with instructions on how to install a program. I'm not going to do that. It is the year of our Lord 2026. I'm sure you know how to install a program. Just Google Netlogo or visit netlogo.org. Go to their download and select the appropriate file. It's that simple. Now, when you open up Netlogo for the first time, it's going to look something like this. If it looks different, you've accidentally opened up Netlogo 3D. Close it down and make sure you open up Netlogo 2D. This is also version 7 and it's in dark mode, okay? So it might not look exactly the same, but what's going to be important is you'll have a bar at the top, a bar at the bottom called Command Center, and a big black square in the middle. I'm also very highly zoomed in here, at least for the world view, so it might look, again, a little bit different, but not majorly. Now, before we begin, let's understand the interface that we're looking at. We have the normal toolbar, File, Edit, Tools, Zoom, Tabs, and Help. We're not going to be doing much with that, but just while we're here, you might as well open Help and click Netlogo Dictionary. You will be spending a great deal of time in the Netlogo Dictionary. This is an invaluable resource for explaining what certain things do. Now we have these 3 tabs right at the top. The interface, this is the visual interface that you'll be interacting with, and kind of this is where the modeling happens. We have our info tab. We won't be concerning ourselves too much with this. This is the place where you would summarize what the model is doing so that someone who didn't write it or may not understand how to read the code can get an idea of what is happening in the model. And then there is the code tab. This is where we write everything that will happen in our code. You can hit separate code window, which can separate things out. I prefer to code like that, but for the sake of this tutorial, I won't be. In the middle, we have model speed. Depending on how resource hungry your model is, it might run way faster than your mind can perceive. So if it's going too fast and it's a blur, scroll this down to the left side, to the minus side, and slow things down. If it's going too slow, for whatever reason, you might need to speed it up. For the most part, just keep it in the middle. And be aware that if you're new to this and it looks like your model isn't running or it's stalled or it's stuck, you've probably got the model speed set right down to the bottom and things are just happening really slowly. Your code is probably working, but you might have set the speed wrong. We also have a few different things. Now, if you are on an earlier version of Netlogo, things are going to look a little different, so I'd recommend using 7. It is the superior version at the moment, so there are lots of good reasons to use version 7. But we have our drop down for adding widgets. Widgets are things we're going to put in the interface. Okay, if we're going to have buttons or switches or other things, they're going to go here. Align widgets is just a way of aesthetically making things neat on the page. We'll deal with that later, but I'm sure you can figure it out. There's no way to do align widgets wrong. And then we have these 4 buttons. We have our hands so that we can actually interact with our widgets. We have our dragging value so that we can select things and change shapes and sizes. We have an edit interface item where we can just edit our items. You don't always need to use that. You can just right click as well. And then of course we have our delete option, which is useful. We can also use right click as well. If you can't interact with your items, it's because you're not on the little hand icon. I'm sure you'll pick this up soon enough. View updates tells us whether the world is active or not. We're not going to concern ourselves with that right now. Just leave it turned on until you're running really intense programming. There's really no reason to turn it off. We can have continuous or on ticks. No point in discussing that just yet. Just leave it on continuous. And we have our settings tab, which we will cover later. But while it's opening, our settings tab governs the shape of our world. You can see here that our world has the 0, 0 coordinates set right in the middle. It spans 16 pixels up and 16 pixels down, and 16 pixels left and 16 pixels right. That 16 plus 16 comes to 32, but of course we have our 0 coordinates on the x and the y. So we are currently in 33 by 33. Our world wraps horizontally, meaning if something disappears off the right side of the world, it'll reappear at the left side. And our world wraps vertically, so if something goes down the bottom, it'll appear at the top and vice versa. We can change some features in here, but we're not going to for the moment. This is a fine place to start. And finally, we have down here our command center. This is when if the code specifies certain things to be printed out while we're debugging, or we want to get answers, or we need a log of our records, they'll show up in the command center, which we can clear as required. We can also have it over here on the left, which I personally prefer. And we have our observer where we can type in commands. Nothing named hello has been defined, but if we typed in commands here, they will appear in the log. Print hello world. Hello world. There we go. Now, if you're here learning about agent-based modeling, I assume you already understand what agent-based modeling is, and I won't be going into a great deal of detail. Read chapter 1 in either of those 2 textbooks I recommended. But suffice to say that I think I have to say that when we're talking about agent-based modeling, we're talking about agents. Agent-based modeling is a subset of object-oriented programming. So rather than building the rules for a large world, what we're doing is building rules for specific instances of things within a world and then letting those instances interact with each other. The basic unit of agent-based modeling, the basic agent, is a turtle. I will use the word turtle. I'll use the word agent kind of interchangeably. They're synonyms. But if I use the word turtle and you don't understand, it's because I'm talking about the specific little doodad that's going to be walking around the world. Now, just for the sake of demonstration, I'm going to create a turtle. I'm going to use the observer, but we'll do it in a more robust way first. Now, if you are playing along at home, it would be in your interest to identify how to create a turtle from the library, from the dictionary rather. So we want to go into our categories. These are broken down clearly into turtle, patch, links, agent set. Some of these things won't make sense yet, but they will. I said we're interested in turtles, so let's click on the turtles. These are all of the turtle related commands. Back, can move, clear turtles, create ordered turtles. They are in alphabetical order, so you might have to scan through this yourself until you can find something that seems appropriate. Now, I know we want to create a turtle. Okay, there are multiple ways for turtles and things to spawn in Netlogo, but I want to create one. So I'm just going to type in create and see what shows up. And we have two options here, create ordered turtles and create turtles. Okay, let's click on create turtles and then number. So below here is going to list the way in which the command should be specified both in the observer or in code. And here we're going to create a turtle, and we're going to want 1 turtle or 10 turtles or 999 turtles. We will type create turtles and then a number. So if we try that together, create turtles 1. We have a little triangle. Okay, in this case, the default shape for a turtle is this kind of triangle with a divot at the back, and they are generated. They are random colors and random orientations. Now, if I want to create 10 turtles, I can write create turtles 10. And what we have here in the center of the screen is kind of a multicolored star. If I do this again, it happens again and again and again and again. What's happening here is that the default position of all turtles is 0, 0. Remember, the origin in our world. So we now have 10, 20, 30, 40, 51 turtles all in the middle. Let's check that. We can issue a command in our observer to kind of just check what's happening in the world, and I can type in the term count turtles. I'm asking Netlogo to count how many turtles there are. It tells us there are 51. Okay, so we're learning commands as we go here. We've got create turtles, and we've got something like count turtles. Now, there are multiple ways we can clear the screen. We could use clear all, okay, which is a useful command for wiping everything from the system as we go, and we will use this regularly. Clear all is a good way to just wipe everything, but let's say I'm pressing up here, and it's cycling through the history of our commands. Okay, so create turtles 10. We now have 10 turtles. Let's check. Count turtles 10. Excellent. There are ways to remove turtles individually or in small groups, and this is going to be our first example of learning how to write a command. When we want a turtle to do something in Netlogo, we need to ask it to do something. Okay, so I can type something like ask turtles. I want the turtles to do something for me. I'm asking the turtles. I am asking all the turtles. And when I want to get rid of turtles off the screen, when I want them to disappear, I'm going to ask them to die. Now you'll notice that I have used square brackets here. So I'm going to ask the turtles, and in Netlogo, we open square brackets in order to write our commands. Okay, I've asked all of the turtles to die, and you'll notice they've disappeared from the screen. Let's check. There are now no turtles in our world. So we can now create turtles, and we can now get rid of turtles. We can get them to appear, to disappear by clearing the entire model, the entire world, or we can ask them individually to die. So now we have seen some really, really basic functionality of the world and writing some commands. Let's begin and really starting to get our heads around making things happen in a more reliable way, the actual kind of programming of it. Now, when we're writing a model in Netlogo, we're almost always going to start out exactly the same way. We're going to build some basic functionality into our interface so that we can then start doing things reliably and repeatedly. So the first step will almost always be to create a widget. So go up to create widget and hit button. Place that wherever you want. Somewhere over here on the left is nice and tidy. And it's going to open up this little other window that's going to allow us to write the command name. So the thing we're going to call when it's pressed. And the first one we're always going to create is usually something called setup. I'm going to use the term setup. You could call it Wazamagoo if you wanted to. It doesn't matter. But Netlogo is built around natural language, so the clearer you can make it for yourself and others, the better. Now the command will be setup. You can have a display name as well, Wazamagoo, right? Wazamagoo means nothing. It's merely aesthetic. The command, the thing we're actually interested in, is setup. Usually the only time we'd use a display name is if we had a setup, if we had a command that was really long for some reason. Set up the model for all the turtles. That's a silly command, but you could just shorten it to setup. And if you have more complex models, this is more or less what you'll end up doing in time. But for the most part, just type in a nice simple command called setup. You'll see it immediately turns orange. This means it doesn't do anything because our code we haven't told it to do anything in code. Now, if we write setup, you'll see that it's white. Okay, we haven't responded to the button yet. We haven't written the procedure. In Netlogo, the way you would do this for any block of code is it will always begin with the word to, and you'll see that it's not white. Okay, to, and since we wrote the command to setup, setup. Now we also need to end this. We need to close it out. So you'll always begin by writing to, command name, and end, with a few spaces in the middle for whatever it is that we want to do. Okay. Now in Netlogo, the interface is normally pretty natural. If it's a colored piece of text, it's a primitive. It's a piece of writing. It's a term. It's code that already does something, and we don't have to create it ourselves. Now you can see here that the interface is still red, but our button is blue. We can hit, let's delete that just to show it. If we hit check, for example, after having deleted all of the code in there, it's red and the interface is red, indicating something isn't going to work. But if we write to setup and end and then hit check, nothing happens. Now, if I accidentally type in the wrong thing, we're going to get an error over here as well. Okay, so to setup, and now it works. You'll notice I can press the button. See the color flashes when we press it, meaning that the button is now functional. Now the thing that we want to do is create turtles in our setup. So we know how to do this from before. Create turtles 1. Okay. I like to hit check very regularly, and you as a beginner will also want to do this to work out if you've done any spelling mistakes. And here you can see we are now creating turtles in our world. But we're not creating just one, we're creating one, then another one. Every time we hit the button, we're getting a new one. So in our setup command, we're going to want to use the term clear all that we used before. Okay. Now, as you can see, we have one little turtle flashing up in the center at different orientations and different colors each time we press the button, because when the button is called, what the program does is clears everything and then creates a turtle. Okay, so everything's working just as we want. Now, the problem we identified before was that the multiple turtles, whether we have more than one, they all keep spawning at the origin. We don't want that. So we're going to create a set of commands specific to the create turtles function. So we open up our square brackets. We open a square brackets and close it immediately. I like to open and close immediately. It's much easier to kind of keep track of all of the commands you are making. Now, we know that the turtle is spawning at the origin at 0, 0, at x coordinate 0, and at y coordinate 0. So let us quickly visit our dictionary and identify if there's something here about x and y coordinates. Okay, and if we look through, we see there's a command called set xy. Okay, and if we click on it, it sets the x coordinate and the y coordinate. It is equivalent to a slightly less elegant way of doing this, which is set x core and then a value, I don't know, 10, set y core 9, 8. And here, if we do this, all of the totals will spawn at this new coordinate, okay, which is somewhere else. Set xy, okay, 10 and 10, or 10 and 8 again. We can recreate the same functionality, or if we reverse it, 8 and 10, they appear where we tell them to. Okay. Now, we have 10 turtles. We might have more. Perhaps we want them at different locations. So how do we make sure that each one has a unique location? Now, one way we could do this is to repeat the command create turtles 1, repeat it 10 times with a different set of coordinates. But Netlogo is very comfortable in dealing with randomness. Okay, we want a random value. Okay, we can use random x core or random y core. And what that's going to simply do is pull a value from all of the possible values here in the world. So if we had set xy, we could just type random x core and random y core. Now, Netlogo works by running, basically, this is a repeat function. It's going to create one turtle and then set it at a random location and then repeat a second turtle and set it at a random location. So as you can see, each time we click the button, the turtles show up at sets of unique x coordinates and y coordinates, which is our first command. Great. Let's say we have some interest in making sure that our turtles are identifiable to us in some way. We want them all to be a certain size or color. So let's go back to our turtle related commands. Now I'm just going to hit color here. I can see that the first thing that matches with color is in patch related, but we don't see anything in turtles. Okay, now this might initially be a little bit confusing, so we're going to have to learn something here immediately about our turtles. It's that our turtles contain variables, some default variables without our having to set them. So if we select a random turtle by right-clicking on it, we can see a little window opens up, and I look at turtle 8. This one just happens to be the 8th turtle created. This one's the 6th. This one's the 1st. Or rather, this is the 2nd one because counting begins at 0. But let's look at turtle 1. We inspect it, and we get a little window that looks like this. I can't make it bigger, I'm afraid, but it'll begin with who. Who is the ID of the turtle. This is turtle 1, that's its number. We can hit watch and it'll also identify it for us, which is useful. Its color is color 5, which corresponds to the RGB grading of gray. Its heading is the direction it's facing, its x coordinate and its y coordinate. So this one's quite near the center. You can see that its x coordinate is not 0 or 1, but it's actually a floating or a decimal value. It's 0.691489. And its y core is 2.385102. We asked it to choose a random coordinate from anywhere within the world, and that's what it's done to like 20 decimal places. We can see these other variables. There's shape. So the default shape is this triangle with a divot at the back. Let's not worry about its label color. It's a breed, which is its breed is turtles, which is the default value. We'll come to breeds later. We see that it has it's not hidden. Okay, so hidden question mark is false. A thing we'll come to later. But the thing we're interested in here is size. In fact, we're interested in two things: size and color. So let's say I want the turtles to be larger. We have identified that we can't see a size command here in the turtle related, but we know that the turtle does in fact have a variable that we can manipulate by looking at its properties. So if we want them to be a certain size, we can just type set size. Now, there might be an inclination to just write size 2. If we did that and hit check, it's not going to work. It's saying the command is unexpected. What it's telling us here is it doesn't know what to do with size. When we have a variable that is pre-existing, that we've already established as part of the model, to change it, we simply say set size. Okay, we can say set size, or we can say set color. Okay, now if we do this, it's going to cycle through creating all of the 10 turtles. It's going to give them unique XY coordinates, but they're all going to have the same size and they're all going to have the same color. We can go back and we can hit check. It works fine. And you can see here, they're bigger and they're all the same color. Now, there are ways to give them unique sizes and different colors according to distributions and probabilities. That will become clear later. But for the moment, we will be satisfied with having quite large red turtles. Now that we've established our world, we need to be able to ask our turtles to do something within it. So we need a new kind of command. So we've set the world up, we've established the initial parameters of the world. Now we need to do something with those initial parameters. So normally we would create another widget, a button, that's called Go. We have the same interface as before, and we're gonna make the command Go. We could have the word, we couldn't have the word run, because you can see here that run does something different. If we look it up in our dictionary, run is part of control, flow, and logic and does something slightly different. We can't make the model, we can't overwrite existing primitive commands. So we're going to use the term go. You'll see here there's a button here for forever, a little checkbox. We're going to leave that unchecked for the moment, but we will return to that in due course. You can see here it's turned red because the model doesn't know what to do with it. So we're going to create a new command block to go, and we're going to immediately close it. And here is where we tell our turtles to do things. These are agents, or these are turtles. We would like them to walk around the world. Now, if you remember before when we asked our agents to die, in order to get our agents to do something, we need to ask them to do something. I can't say something like make turtles or just turtles and then write our commands here, walk forward or something like that. We can't do that. We have to ask our turtles. There are other kinds of agents in these worlds that we will develop over time. And so if we had a different kind of agent called a person or a plant or something that's like a rock or a wall or something, we might type ask rocks. But right now we're simply dealing with turtles, so we're going to ask all of the turtles. Now again, if we look at our dictionary, we could go through this and find that there's nothing in here that's like walk. We see the word walk show up somewhere else. It's not what we want. So we'll return to the top and try to identify if there's anything else here that is useful. Now, I know the answer to this. Now, when I type in the term forward, we have something that might be useful. We can also see that there is right and there is left in here. Okay, since this is agent-based modeling, it's object-oriented, we're going to ask our turtles to move forward. So let's check that this is the right thing. Forward plus a number. The turtle moves forward by a number of steps, one at a time. If the number is negative, the turtle moves backwards. So if we want our turtles to move, we're going to ask them to move forward 1. They're going to move 1 step forward. You might have noticed this jumped here. Netlogo is quite useful that if you hit the tab button, it automatically indents into a nice, neat, nested hierarchy. So here in Go, we're going to ask our turtles to move forward 1. Okay, let's check. Turn from red to white, meaning everything is functional. So if we hit here and write go, click, 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 we can see that the agents are all moving forward in the direction of their pre-existing heading in straight lines. Now you can see here that I'm clicking, 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 and they're moving only as fast as I can click. But if we go up here and select our interface item, open up Go by double clicking, okay, and I hit forever, now it's just going to keep running continuously. Go back and select the hand, and they're moving so fast we can't see. If you remember, I talked about model speed before. They're moving too fast. Now we drag the speed down until we can see our agents moving. Okay. So as you can see here, it's just executing the go commands over and over and over, which is to ask each turtle to step forward 1. But this isn't that interesting. Okay, there's not much we can learn here, and there's not much functionality in just having essentially turtles acting like bullets moving from left to right or up to down and looping endlessly forever. So by clicking go, we turn that off, and we're going to start to create what's known as a random walk. We want our turtles to move in kind of strange and random directions in order to develop some kind of emergent property. Now we know from looking at our dictionary earlier that if forward makes them go forwards, and we have these terms right and left, we can ask our turtle to turn. Now, one thing we want to understand about our turtles is that right now, this turtle's heading is something like, so 0 degrees is up and vertical, 90 degrees is out to the right, 180 is straight down at the bottom, and 270 is out to the left. Okay, and 360 is the same as 0, so it's above. If this is 0, 90, 180, its heading, the direction it's pointing is, I don't know, about 190 or something. Let's have a look. Its heading is 203. Okay. You see here, if I change this manually, I can make it point in slightly different directions. So 0, it's going to point upwards, 90 to the right, 180 to the bottom, 270 to the left, and 360 is back up to the top. Let's return it to its original position of 203. And in fact, let's change its color so this one stands out. Okay, we set its color to 2. It's a gray color. Okay, it'll stand out from the others, and we can hit the watch button, which makes it stand out to us. So we want it to turn left or right, and we know that its heading can have a heading anywhere between 0 and 360. And we know from here that if we ask it to turn right by a number, it's going to turn right by that number of degrees. Okay, if it's positive, it turns right, but if it's negative, it turns left. But we also have left. Okay, and if the left number is negative, it'll turn right. So it doesn't actually matter if we're going left or right. What matters is the number. Now, if we wanted it to take a step forward and then turn a certain number of degrees, we might say turn right 15 degrees. This is kind of not random, okay? What's basically going to happen is that our turtles are just going to move in large circles. Well, actually not that large. They're going to move in tight little circles and just repeat the same steps over and over forever. So what we want is the turtles to move some amount to turn right or potentially even left some amount of distance that will produce kind of a random walk. So if I wrote 15 or 200 or 360, it's always going to do the same thing. What we want is some way to generate a random value. We're just going to type in the word random, okay? Because we know that we had random X core before, random Y core. So let's keep searching random. That's not useful. Random PX core, not useful. Random PY core. Randomness, is that useful? With local randomness, the commands are run without affecting subsequent random events. Hey, this doesn't sound quite like what we need. this is kind of confusing. Let's ignore that particular thing. Oh, and you'll see that I've just gone searching random again, and I can see this thing that's saying random 10. That seems like what we want. So let's go and find that term, random. It's in mathematical. We have things like plus, minus, mean, max, mode. We can see random. We see some other things, random float, random exponential, different kinds of distributions, a gamma normal or a bell-shaped curve, a Gaussian distribution or a Poisson distribution, random seed. These might be a bit too complex for us right now. Let's just look at random number. If the number is positive, it reports a random integer greater than or equal to 0, but strictly less than the number. So if that was random 10, or rather down here, random 3, it's going to be able to produce 0, 1, or 2. Okay. If we said -3, it's going to produce 0, -1, or -2. If we said 3.5, it's going to go 0, 1, 2, or 3. We'll deal with decimal places later. But essentially, Netlogo starts counting at 0, and if we want 3 options, it's going to go 0, which is our first option, 1, which is our second option, 2, which is our third 3 option. Okay, so we want our turtles to turn a random amount of distance between 0 degrees and 360. So that's going to produce values between 0 and 359. Remember, 360 and 0 are basically the same when it comes to these angles. And so we're asking it to turn right a random value between 0 and 359. Let's check, set up, go. And you can see here that the turtles are all jittering in random directions. Okay, they're doing a random walk. They're kind of stuck on the little spot doing a little shuffle, but they are doing a random walk. What if we wanted to be able to see this more clearly? Okay, well, let's use our observer in the command center, and we're going to ask our turtles to make themselves visible. There are a bunch of tools that might not seem obvious in the dictionary that are very useful for debugging and for just working out what's happening in your model. One of them is called pen down or pen up. If we inspect one of our turtles, as before, we can see that there's pen mode and it's currently up. We could change it here to down and see what happens. And you can see that that particular turtle is leaving a little scribble behind it. But what if we want all of our turtles to do that? Well, I'm going to ask turtles. We're going to ask all of the agents that are turtles in this, and we're going to say pen down. Ask turtles, open command with square brackets and close it, and write pen down, and hit enter. Now all of them are going to do it. Okay. And what we can see here is that they're genuinely doing a random walk. Now, what if we don't want a fully random walk? Nothing is really random, and a random walk like this that's a little bit of a scribble is not really that useful. I'm going to hit setup again to clear the screen. So now we have a fresh world to work with. What if we don't want them to have truly random? Well, maybe we could get them to move random 90 degrees. If we did this, this might seem the intuitive solution. They're going to turn less amount of degrees, but there's actually going to be an issue. Okay, as we can see here, even without asking them to put the pen down, but I will, they're all moving in kind of loopy-loop circles to the rightward direction. Okay, so this is much worse than a random walk. It's just a noisy right-hand turn that they're making. So rather than looking from, we saw a bunch of other distributions. So when we looked at random before, and we know that that was in maths, we saw random, random float, random exponential. And here, if you don't know anything about statistics, this might not seem intuitive, but if you do know things about statistics, we're going to look at our normal distribution, our Gaussian distribution, or our bell-shaped distribution. Here it's called normal, random dash normal. And we see when we click on that, it's going to show us all of the options for different kinds of distributions. Reports a value according to the mean, and in some cases, in the case of the normal distribution, the standard deviation. I'm not going to explain the maths of mean and standard deviation. I'm going to assume you understand that. So what we can do here, instead of using random, we can use random normal. And let's say we want random normal 90 and we hit check. It's saying unexpected closing bracket. Now, that's not going to be super intuitive to begin with, but what it's saying is, with experience, you'll learn it's saying, hey, we're missing an instruction. This is closed too soon. It's unexpectedly closed. Why is this happening? We want it to move less randomly from a normal distribution. Well, what we need to do is give it a mean and a standard deviation. Now, if we want it to not circle in rightwards or leftwards, we might want to make our mean 0 and our standard deviation something like 45. So the average value is going to be somewhere in the middle, but it's going to be drawing from a standard deviation where plus 45 and minus 45 are within one standard deviation of the mean. And then, of course, 2 and 3 standard deviations become less and less probable. So if we have our code here that is ask turtles, take a step forward, then turn right to a degree that is centered on 0, but kind of equally probable of showing up left or right, being negative or positive, what we see here is we have kind of a more straightforward walk with some equally distributed left and right, which is nice and useful. We can make this number bigger or smaller. Okay, so it's going to be more random, so to speak, if we use 90. And if we even go all the way up to 360, we've basically just repeated the random value from before. There are some caveats, it is slightly different, but we do end up getting a little bit of a shuffle. So if you want a kind of forward walking situation that is semi-random, okay, a bit more like a drunk toddler or something, we can use our random normal function. Now, one final element of today's class in developing the random walk is let's look at making comments and making things go away because, hey, this is all red and it's kind of difficult to see what's happening. So let's stop that. Now, we want them to go back and be random colors. We could tell it to choose, we could develop a function for generating random colors, but we already know the default is to give our turtles random colors to begin with. So we could either delete this and go back and create lots of random colors of our turtles, or we could keep it because maybe we want it later, but we could just cancel it out. And in Netlogo, that's the semicolon key. Okay, so the text turns to gray, meaning it's not active, and we essentially run the code without running the set color red. This is also useful to put after a command if you want to type something to kind of annotate your code to make sure you understand it later. So I like to use 3 to demarcate it, and I could write something like this command called setup initiates the world. And then I might go through and add additional comments, clear all, deletes and resets all information. I create 10 turtles are created, and their X core and Y core are randomly set from possible X and Y values. All turtles share the same size. All turtles are red, okay? But not while it's gray. The setup command is finished. Okay. And so here, if I ask them to put the pen down again, we can now see their semi-random walk, and it's a bit clearer to make out on the screen because they're each leaving a trail in their own unique color. And so what we've accomplished today is actually quite a lot. We have looked at the interface of Netlogo. We've engaged with the dictionary of Netlogo. We understand how to create widgets and how to modify those widgets as required. We've used the observer and the command center. We've learned specific kinds of commands like pen down, and we've learned how to inspect our totals. We've created two specific kinds of commands in here. I've re-annotated these so they're a bit clearer. All of this code will be made available to you all as well. We've learned how to reset our world to create any number of turtles we fancy. We've drawn from different kinds of randomness. In this case, we've drawn from randomness of the possible values of the world, okay, which is a very useful thing to be able to do. We've worked out how to disable commands to set different kinds of randomness in color. We can set sizes. We've asked them to move forward. We've learned how to get them to turn right or left, and we've worked with the random normal function and the normal random function, the ordinary random function, which draws from a flat distribution. In our next session, we're going to look at different kinds of widgets that include using switches, and we're going to create objects in the world that the agents will perceive and move towards with some kind of sensory capacity. Naturally, the traditional goodbye salutation here is like and subscribe. I intend to complete this series and really work through the kinds of lessons and commands and instructions that would have made my life easier 10 years ago, as well as a big number of tips and tricks that I've developed over the last decade. So do stick around. I will be writing this, and by the end of this series, at least this beginner series, you'll be capable of being a threat to yourself, but you will at least be able to understand how to read a paper that's talking about agent-based modeling. That's my cat at the door. Maybe she'll make a cameo. Maybe she'll make a cameo on the next one.